I don't know who's out there, man, but let's see what we can see here. Let's see what we can see.
I
Not
don't
sure.
know who's out there, man.
Not sure who's out there at all, if anybody's out there, but I'm gonna give it a little bit. See who shows up, how many viewers I got in chat. I don't really need anybody on the panel because this live stream, I'm doing this because my software recording is set up for like 1 hour presentation. So this might take more than an hour because I found some new, new information regarding flat Earth guidance law. Now, this was interesting. This was some interesting shit that I found because kind of baffled me a little bit. It involved vehicle launches for the space shuttle and rockets, and guidance systems for missiles, rockets, manned space vehicles. This time of day, it probably ain't gonna be many people viewing this whole thing, but I'm just gonna do this FYI by the way, and anybody who's interested in it can view it later, make their comments. I'm not really gonna focus on what's going on in chat or nothing like that, because hey, I'm not gonna really wait for nobody. To be honest with you. But I'm gonna do the share screen right now so that this shit can be seen, and everybody can see this shit because I think it's fucking interesting as hell. So what I'm gonna do here is pull up these docs, and we can just start going through them one by one, baby. So this first document, and just before I begin, if you want to know where these documents are, just type in flat earth guidance law, and you'll pull up a whole host of documents you'll see. You can come back to the video, type in the title of these documents. It's there for your own viewing. But I'm going through this with you guys for the first time, the very first time. I have not had a chance to look at these in advance. You're seeing this live and raw. So whatever we read together, that's what it is. I'm not gonna speculate. I'm not gonna try to change shit and put my own spin on it. You're seeing it exactly as it is. No teleprompters or fucking scripts here, baby. Giving it to you raw. It's not what you know, it's what you can prove. NASA contract report 467. Optimal guidance law development for an advanced launch system. How about them apples? This is April of 1995. Langley Research Center, prepared for Langley Research Center with grant. Oh, this was used with a grant. NAGI 939. You can go to grants.gov, search and check all this shit. Really do that research, people. So let's go through this and check this out. Let's go through this. Table of contents, background, research contributions, report organization, symbols and abbreviation, problem formulation, equations of motion, assumptions and simplifications, aerodynamic model, launch vehicle configuration, atmospheric model. They break it down here. We're going to figure something out on this. We got to get down to the nitty gritty and stop fucking spinning our wheels, man, going around in fucking circles and shit, talking about the same goddamn fucking thing every motherfucking week, man. That's all you see on these fucking channels. Recycle after recycle after motherfucking recycle. Playing last year's motherfucking episode this week. Man, hell no. We gotta go somewhere with this shit. We can't be keep going around in fucking circles with this shit. No way. Wind shear investigations. Okay. List of illustrations. Well, we can go through. I'm not gonna go through this whole fucking thing. This shit could take hours on hours and hours and hours, and I'm not gonna spend hours and hours and hours and hours on this fucking thing. But it's really to be put out there for you guys to start doing your research, and then you start looking through these documents, develop information and expand on the information you're seeing on your own so that you can put together your own video. It's okay if you reference the document. It ain't my fucking document. It's NASA's document. I'm just showing it to you. That's it. So I'm curious about something. Let's do this. I always like to do this just to see where they have the term flat earth inside this document. So let's check this out first. Let's see what's up here. Let's see what's up. But you always want to do kind of a textual search. Okay, here we go. We got 2 of 4 pages. Let's go back to this shit. Hold on. Page 1. All right. Let's blow this up. So what are they talking about here? Using simplified models. Chandler and Smith have developed an IGM for the Saturn V vehicle. It is based on a flat Earth, no atmosphere model, and is further simplified with linear angle steering guidance. The guidance solution requires solving only a set of linear equations. 10 years later, the Boeing Aerospace Company adopted the linear tangent steering guidance. We're going to get to that. This linear tangent steering guidance, I've got that document as well. So we're going to get to that bad boy. As the baseline program for the Space Shuttle's PEG. We need to know what the fuck some of that shit means too. PEG. I'll get to it. Using an approximate gravity model, the program is extended to handle the spherical Earth case, and the solution is solved by an iterative algorithm. Okay, so let's see where else they mention this flat Earth shit. Okay, let's go here. The approach requires an analytic zero-order solution and quadrature evaluation. The analytic solution is again based on a flat Earth, no atmosphere approximation, and the neglected dynamics are introduced as perturbations. Solution is obtained by expanding the HJB equation. In this method, higher order state histories are not required, and higher order corrections for the constants are obtained by partial differentiation of the power series solution to the HJB equations. We need to start checking some of this shit, man. See what they say here. Third, there's another page where they mention flat Earth. Report organization. Section 2 presents, let's skip here. Right. The second is a regular perturbation approach based on the zero-order solution for a flat Earth, no atmosphere assumption. Man, I'm telling you, if they come on, look. When I say flat Earth, I want to be clear. I don't mean the whole fucking system. I don't give a fuck who that offends. I don't give a fuck who that goes against. I don't have any loyalty, any allegiance to any of these motherfuckers. When I say flat Earth, I don't mean the whole system. I mean the earth I walk on, the dirt, the concrete, the stone, the pebbles, the rocks. That's what I mean. When I say flat Earth, that means the fucking earth I walk on. Okay? I crawl on. I get my ass knocked down onto. I ain't never had nobody knock me on my motherfucking ass. But that's what I mean when I say flat Earth. So understand this. Everything I put out, all the documents I show you, I know what the fuck they mean. I know what they mean when they say based on the zero-order solution for a flat Earth, no atmosphere. Okay? They're talking about the ground. They're not talking about the whole system. They may be talking about the first 2 layers of the atmosphere, which is the troposphere and stratosphere. That could be flat. I already talked about that in another video. But let's go on with this document. So this is all about guidance systems. This ain't going to be a long post in here. This is going to be a long video at all. So, and here we go here. The result, let's see here. Assuming that the dominant forces on the large vehicle are thrust and gravity, an attempt is made to treat the atmospheric effects as perturbation effects. To further simplify the problem, spherical Earth effects are also considered as perturbations. These effects are only apparent when the vehicle reaches orbital speed near the end of the flight. The result is similar to the maximum horizontal speed transfer problem in, they're referencing some other reference, number 33, for a flat Earth, no atmosphere situation. The differences here are that the mass of the vehicle is varying, the dynamics are discontinuous, and the terminal boundary conditions are specified at an unknown final time. We now recast the dynamics of equation 2.5 in a regular perturbation format as in equation 3.8 in accordance with the above desired approximations. So here we go with this complex cosine sine mathematics meant to confuse the fuck out of anybody who is not mathematically fucking inclined. All right, don't get discouraged, people. Just don't. So what we need to do is go back to something here, because I want to see the table of contents with regard to the advanced launch system. Energy state approximation, two-state model, launch vehicle application, level 3 formula, first order solution. Let's see here. Where are we going to on this fucking thing? List of illustrations. So let's go to page 8, and then we're going to jump ahead 11 all the way through to see what some of these illustrations are. Because, you know, we're all visual learners, right? So let's go to some of this shit, and then we can let me look here. Again, in this document, some of this stuff's pretty interesting. I'm definitely going to go over it with a fine-tooth comb. The hell is this? The hybrid guidance approach delivers over 99.9% of optimal performance and orbit injection accuracy, while the control computation is completed in the tenths of a second on a Spark station. I'd sure as hell like to know what the hell that is. I want to know what this is. Spark. Okay. Let's see something here. Advanced launch systems. Man, understanding how they put all this shit together and how it works and how it functions tells you exactly, will definitely tell you exactly what it is you're looking at, and if the shit you see and if the shit they're telling you is actually fucking possible. That's what this is coming down to. You have to read this. You just have to read this shit. You just have to. Let's go to page 8 because they show some illustrations, man. Let's go ahead to page 8. Problem formulation. All this math, man. Okay, here we got some illustrations right here. Reference meridian. These are some of the models I was showing you before. Local horizontal plane, Earth fixed reference system. Coordinate systems, Earth fixed frame OXYZ, local horizontal CIJK, and wind frame. That's an interesting model. Fixed Earth reference system, huh? That's interesting. Okay. Again, we're just browsing through, people. Just browsing through. Constant fuel rig for purely rocket propulsion system. The rate of fuel consumption is proportional to the vacuum thrust, where GE equals UA. Let's see here. And it goes non-rotating Earth. Here we go. Let's see what we got to see here. Non-rotating Earth. The Earth's rotation, WE, is small. 7.27 times 10 to the minus 5th to the -5 rad to the -1. And the term R times WE to the second power, which represents the transport acceleration, was neglected. Okay, let's see what else they. Okay, here with it. The term 2 times W times E times the velocity, which represents the Coriolis acceleration, may reach 0.1 g's times energy at orbital speed. Here, g times energy is the gravitational acceleration at Earth's surface. However, the vehicle reaches orbital speed sharply near the end of its flight phase. Therefore, the dominant effect of this term is only apparent for a short period of time, and setting W times E equals 0 does not produce any significant error. All right. Planar motion in actual flight, the lateral maneuver is short. This magnitude is dependent on the launch site, which is selected as close to the equator as possible so that a wide range of orbital inclination can be achieved. That explains why they have these fucking launches in Florida, huh? A large amount of lateral maneuver is typically not required, and the desired flight azimuth can be achieved very early in the flight. Hence, for the simplicity, it is assumed that there is no out-of-plane motion by setting B equals W times J equals 0. Okay, we're not going to go over all that shit. Let's keep seeing if we can see some pictures here of some of this shit. Okay, so here goes a picture of the aerodynamic model and launch vehicle configuration. Aerodynamic model is obtained from 27. It corresponds to a generic model of a heavy lift capacity two-stage launch vehicle based on a CFD, computational fluid dynamic analysis. That's what CFD stands for. The vehicle has an asymmetric configuration as shown in figure 2.2 with a booster mounted atop the main body. The booster produces a shadowing effect above supersonic speeds during the first stage of flight. This shadow effect reduces the C times D, the computational dynamic at positive angle of attack, and the computational dynamic exhibits a non-convex behavior. All right. Here we go. Kind of explains why they got to put this motherfucker right where they put it. Generic advanced launch system model in the sixth plane. All right. A lot of pictures here. Whoa, whoa, whoa. Interesting. This is some interesting stuff. Due to the non-convexity in the computational dynamic, the Hamiltonian also becomes non-convex. Yeah. Atmospheric model. Let's see. The atmospheric model is based on the 1975 U.S. standard atmosphere profiles of normalized density, pressure, and sound speed with respect to the reference values at the Earth's surface. Now, get this shit. Now, people talk about gravity, right? Where the fuck did they mention gravity in here? They're talking about the atmosphere. They're not talking about any gravity at all. They're talking about density, pressure, sound speed with respect to the reference values at the Earth's surface. Here goes the numbers right here. These are the standard numbers. Are given in figure 2.10. To investigate the effect of wind shear, a mean winter wind profile over Kennedy Space Center is used to model this non-stationary atmosphere. Non-stationary. The profile is shown in figure 2.11. It indicates a head-on wind for a vehicle launched due east, and the vertical and horizontal north wind speed components are assumed to be 0. Analytical approaches, single perturbations. A lot of math, people. A lot of math. Energy contour. Let's see. Angle of attack profile along the reduced solution. This may be explained by a lot of these early fucking launches just were unsuccessful to begin with in the first place. They didn't have all of this fucking detail, man. A lot of this shit took off and just exploded before it got any fucking where. Two-state model. There's a lot of illustrations, man. This shit is boring. Boring, boring, boring. Plot graphs. It's crazy. Plot graphs. What do we got going here? Okay. You get the gist of this. It's 108 pages, man. It's a long fucking document. Long fucking document. I don't even know where the fuck it takes us. The rest of this shit. You get the gist of it. So let's go to the next one. Let's go to that one that they mentioned, derivation of linear tangent steering laws. Now, this document dated November of 1966. Check that shit out. Prepared Frank Perkins, Guidance and Control Subdivision, Electronics Division, Aerospace Corporation. Prepared for the Commander of Space Systems Division, Air Force Systems Command, Los Angeles Air Force Station. So what do we got going here? What is this guy saying? Linear tangent steering laws. They gotta mention flat Earth in this motherfucker too. I guarantee you. Yep. Here we go. Yep. Program derivations, pitch steering, the geometry, symbols, the derivation technique, downrange disk control for a flat Earth and for a curved Earth. So here we go. That shit's on page 12. We're going to go to that. Again, I'm not going to be biased, man. I want to show it all. Let's see what they're saying. So for a flat Earth, the bilinear tangent steering law was presented in reference for a flat Earth in the form tangent 0 equals a plus b times the time over c plus d times the time, where a, b, c, and d are unspecified constants. For a curved Earth, here you go. Now, I'm going to make the claim that when they say for a curved Earth, they're meaning that the steering changes when you're at higher altitudes and you start to see curvature. So when you're on a flat Earth, you're in a flat Earth atmosphere, say anywhere between 0 feet standing still to maybe 150, 160,000 feet where you have atmosphere, and then after that, there's no atmosphere and the aerodynamics changes. So you got to start changing angles, pitch, yaw, all of that jazz. The derivation for a curved Earth in terms of the notation used herein may be accomplished similarly to the derivation just completed as follows. The derivation just is completed. So once you go here, as you go higher in altitude, you got to switch to this math. Okay? I want to make that fucking clear. Because they're not saying two fucking models exist. Actually, they are saying two models exist, but you're in one environment and then you move into another environment. So that backs up my previous video I put out regarding the shape and design and construct of the Earth. You want to challenge that? You're a flat earther? I'm going to say you're not a fucking flat earther. If you're a glober, you don't agree with this, then show me something that contradicts this, please. Let's see what else we got going here. They break it down for you. You got people who don't want to believe in math and shit. It's funny as hell. You got to understand the foundation of it. Okay. So we already went to that. Well, that shit showed that shit again. Let's see what we got here. That's 1, 2, 3. Okay, that's it. That's the fucking document, people. That's for steering. As you can see, you just type in flat Earth guidance laws and this document will come up. Okay? 1966, people. 1966. So we looked at that one. I want to go to this one. This one looks interesting. Found this one online too. Design and development of an autonomous guidance law by flatness approach. Woo! 2009, baby. PhD defense. This person was defending their fucking doctorate, man. All right. Application to an atmospheric re-entry mission. Let's see where they mention this shit. Okay. Look at this here. 4 international journal papers. This guy's published flatness-based hypersonic re-entry guidance of a lifting body vehicle. Control engineering practice. And there are a lot more fucking flat earthers out there than I fucking thought, man. The whole government's believing in this shit. You got PhDs who believe in it. Fucking Neil deGrasse Tyson. You don't want to fucking admit to this shit, but we know that he believes this too. But again, it all comes down to his debating with guys like B.O.B. have to do with the entire system. The entire system is not flat, people. Part 3 is flatness-based trajectory planning. Let's go to part 3. Let's go to part 3. Let's see. Oh, they showed a fucking space shuttle. U.S. Space Shuttle Orbiter STS-1. Insertion in low orbit of payloads and crews. First flight 4/21/1981. Mean cost per mission $300 million to $400 million. 3 operational vehicles until 2010. Okay, main features. Wow. This fucking thing's got to be balanced for them to put this fucking thing in there. Okay. RCS jets. This is what maneuvers this fucking thing when supposedly it's in microgravity. There go the OMS thrusters. Same thing. This is basically a fucking high-speed aircraft, man. This ain't no fucking space vehicle. 3 main phases. So this is cool. Hypersonic entry, terminal area, energy management, outlanding phase, 3 phases. So when they come back in from, let's say, just under 100 kilometers, right? They got to take this little S-turn type of shit to slow down a little bit to create some drag. So this fucker just doesn't just go absolutely ballistic, just crash back onto the fucking Earth. It's interesting how the injection point, hypersonic phase, terminal area energy management. Oh, it has to actually come back around full circle, come back down to the runway to land. Earth's horizon right here. Sketch of an atmospheric re-entry mission. That's interesting. I've never seen that before. Okay, here we go. TAM guidance problem. TEP dissipation, S-turns. Hack acquisition, hack homing. What are the problems with this fucking thing? Dissipates the total energy of the vehicle from re-entry point. Trajectory constraints, dynamic pressure, load factor, mission constraints, kinematic constraints at ALI. More math. Guidance problems. They tell you where the problems are with the fucking math. The 3D model in flat Earth coordinates. Well, that's interesting. The 3D model in flat Earth coordinates. G represents the constant gravitational acceleration. Atmospheric density. This is some interesting shit, people. Guidance problem statement. Bring the vehicle from ALI point down to the wheel stop on the runway. Similar problem than TAM, longitudinal motion only. Downrange, flight path angle. Constraints. Outlanding handover. Outer gyroscope flight path angle. Extended parabolic trajectory. Begin constant G pull-up. Constant G pull-up maneuver. Interception of inner glide scope. Inner glide scope flight path angle. Runway threshold. Aim point touchdown runway. Woo! 3D equations of motion in flat Earth coordinates are given by, there you go, flat Earth coordinates. I don't see, they don't mention anything regarding the fucking globe or a sphere or the Earth moving. None of that shit's factored in. None of it. Flat Earth coordinates, people. Motion and flat Earth coordinates. They're talking about the ground. The ground is not moving, okay? Even though the vehicle is supposed to be traveling at the same speed as globers claim the Earth is rotating, which is 1,000 miles an hour. The vehicle is moving faster than the fucking Earth. This is some interesting shit. Autonomous guidance law architecture. Interesting. Use flatness approach as the baseline tool to perform onboard processing, atmospheric reentry trajectory planning, reshaping in faulty situations. they gotta use the flat Earth model for all this shit, man. You just can't program it for a globe because we don't live on a ball. You're not living on a curved surface. You're living on a flat surface. You're just not living on a curved surface. Let's see if we can blow this up. Can't see much of this. Let's blow this bad boy up. What is it saying here? Look at this dynamic inversion. Differential flatness. Meaning that the vehicle's got to be level. They're still showing that fucking ball. Measured flat outputs. This is an interesting document, people. I just found this fucker too. Just found it. Flatness-based trajectory planning. Advantages of flatness approach trajectory planning applications. Minimum number of decision variables in the OCP. The optimization variables become the flat output of the system. Okay. Here's the math. State space, flat output space. This is landing. This is coming in to that space. Differential flatness, a brief overview. Differential flatness concept introduced in 1991 by Fleiss, Levin, Martin, and Rochin deals with pseudo-nonlinear systems. Differential flatness. The nonlinear system, x equals f times x and u is differential flat or shortly flat if and only if there exists a collection Z of m variables whose elements are differentially independent defined by, and they show the math, flatness-based trajectory, differential flatness, a brief overview. Interesting. You guys get it. You get it. You get it. You may say you don't get it, but you get it. There's 65 fucking more pages, man. I mean, it's like 40 more pages of this shit. Flat-based TAM trajectory plane, flat Earth, Coriolis and centrifugal forces neglected. You hear that? Coriolis and centrifugal forces neglected, meaning no Coriolis used and no spinning involved. Centrifugal forces. That's called fucking gravity, people. No Coriolis, no fucking gravity. All of it neglected for a flat Earth. It's fucking funny, man. I'm beside myself right now because I can't believe these fucking people been putting out videos longer than me. Of course, I've been researching this shit and looking into this longer than all of them fucking combined. But the fact that now I'm starting to see a lot of this shit, the advent of the fucking computer and internet is allowing me to start looking for this information a lot easier than I was able to, because I wouldn't go and be able to travel to fucking NASA headquarters in fucking Maryland or in Florida to go say, hey, can I go access this document or that document? All the shit's out there. Plus, I wasn't in aerodynamics or mechanical engineering either, so this wouldn't have been something I've probably been looking for. So, oh well. Here we go. This is interesting. Interesting. Parameter, free trajectory duration, atmospheric reentry. This is all the science right here for this shit. Whoa, hold on for a second. They say time being not a relevant parameter during atmospheric reentry, the 3D of model is reparameterized, free of trajectory duration parameters. It says the new point mass model is given by the position and velocity. This model is not flat since b equals 0, but the autonomous observable may be parameterized. Okay. All right. Flat base trajectory. Monte Carlo simulations. That looks flat to me, people. They're using that model. This is interesting. Fault tolerant trajectory. I'm gonna just take you guys through this for the hell of it, man. With modeling, all this gives you a visual of what it is you should be looking at and what you should be paying attention to. Of course, they never show these motherfuckers when they start coming into the atmosphere, because they don't want to really tell you that it ain't in fucking space at over 100 kilometers. Just like they were able to carry that motherfucker on that large 747, right? That's what they're doing. That fucker is landing somewhere else. They're putting it on the 747, taking it back up to high altitude, let it detach just like it did when it launched, and then it comes back into the atmosphere. That's what's happening. That's exactly what's happening. This fucker ain't going into space. This fucker is not going into space. No fucking way. This is interesting. Super quadrices. God damn. Using these models. Wouldn't that be some shit if the entire Earth actually looked like this? Or looked like this? Or looked like this? Or maybe look like this? Or maybe look like this? Or maybe it looked like this? Because see, this red right here, that's the thermosphere. That's where it's hot as fuck. Hot as hell. This is where they can't get to. They have to be just on the edge of here where it's not as hot, and then they're coming down. That's why they got to have cooling inside their fucking spacesuits. Because it's hot as a motherfucker where they are. Without it, they probably burn the fuck up. Sweating too fucking much. Of course, their body heat's creating a lot of heat as well, so they have to stay cool somehow. But this is interesting, man. That'd be some shit. A lot of mathematics, man. So you want to be an astronaut, hey? You gotta learn this shit. Learn it all. The question is, how the fuck are they testing this in the real world? Because they can damn sure put together some really interesting print illustrations and computer modeling, but how do you know this shit actually works for real? You don't. You just fucking don't. If it doesn't fit, you must acquit. Thank you for your attention. Thank you for your cooperation. Let's go to another document here. Modern homing missile guidance theory and techniques. So let's check this out. Let's see what we got here. Let's see what we got here. Guidance theory and techniques. Classical guidance laws, with proportional navigation being the most prominent example. So they use this for maneuverable aircraft, supersonic cruise missiles, tactical and strategic ballistic missile reentry vehicles, etc. Okay. Where's this going to take us? Again, we're just scanning, people. We're just scanning, we're just scanning. Lots of math. Lots of math. 9 out of 10 Globers won't want to fucking talk about this shit. I'd say 9.5 out of 10. And the same 9.5, 10 out of fucking flat earthers won't want to talk about this either. They just want to say, hey, no, the earth is round. You stupid to believe the earth is flat. No, you're stupid to believe the earth is a spinning ball. And you'll go back and forth, back and forth, back and forth. But here goes the information right here to support both claims. One more than the other, actually, because as many government agencies there are, everyone on the planet, every group, every department, every agency that's involved in aeronautics, aerodynamics, aircraft design and manufacturing and astronautics, they're all using the flat earth model. So, sorry, Globers, but flat earthers got a way much more really bona fide, credible support on the scientific and mathematical side than you have on the globe side, because there ain't no fucking math in globe mathematics. It's non-applicable. It's non-applicable. They know we're not on a ball. They know it. They absolutely know it. They all know it. But they're not going to come on fucking TV and say, yeah, flat earthers are right. You're right, but you're not 100% right. And you need to be 100%. You can't just be fucking 50%. You got to be 100%. Don't be afraid to change your fucking view. Revise the shit. Please do. Because if you don't, you're going to just keep getting fucking laughed at and joked at and trolled and shilled. Whatever the fuck that means. Okay. They have conditions here. State equation, co-state equation, stationarity equation, boundary equation. What we got here? What are we talking about? We're just talking about the math. The planar intersect problem. So, suffice to say that this paper is based on everything that launches, that's a rocket or aircraft or whatever it may be, ballistic missile, it's all based on the guidance laws, all based on flat earth model computational fluid dynamics, period. How heavy is it? How fast is it going to go? Where is it going to go? How is it going to get there? Here we go. For simplicity, we assume a flat earth model with an inertial coordinate system that is fixed to the surface of the earth. Furthermore, we will assume that the missile and target speeds, all right, velocity over mass, times mass and velocity over time, respectively, are constant. In Figure 2, the positions of the missile pursuer M and target evader T are shown with respect to the origin of the coordinate system. So there you go. So much flat earth talk. So much flat earth talk, people. Flat for days, baby. Let's see what else we can see here. I'm doing like rapid eye scanning right now of this entire document. I'm reading it, but, you know, I'm looking for keywords, man. Okay, again, I'm looking at it for the first time, just like you guys are. So this is not pre-programmed. Okay, what do we got here? PN guidance law. What else we got? What else we got? Rendezvous guidance law. Other optimal homing guidance laws. Now you would think if they were basing this on being on a spinning ball, right? You would think that this line right here for this graph would actually have an arc in it with regard to downrange distance in meters, but it doesn't. It's completely fucking flat, showing the missile trajectory going up in an arc, reaching its apex, coming back down, actually meeting the target based on its also opposite trajectory. So based on the distance of how far this target is away, they can make a determination of approximately when this target will reach its apex. So the missile will also have a specific velocity and acceleration to also hit that apex at the same time. All based on acceleration and time, baby. Really, what they're trying to say is based on fucking luck. Is the math right? Will we hit it or we won't hit it? Most of the time, they fucking miss every goddamn thing they're aiming at, unless it's some sort of laser guided fucking system or heat signature system or some sort of electronic tracking. Okay. All right, you get the picture on that. Constant target jerk. Let me see here. Working through this. This document is 18 pages long. Comparisons. Time to go estimations. Okay. It's a lot of data to go through. Lots of data, references. There goes your authors right there, pretty boys. All right, let's see the last document. Naval Postgraduate School, Monterey, California. It's a thesis drafted in December of 2011. Study into advanced guidance laws using computational methods. Okay, let's see what we got here. All right, we got some flat earth talk. For this simulation, let's blow this up here a little bit so everyone can see it. For this simulation, flat earth approximations are used as the ranges involved in air-to-air combat are relatively short as compared to tactical ballistic missiles, and a point mass model will be assumed for flight dynamics. The following vector equations fully describe the motion dynamics of a free body in space. There we go. There's nothing talking about gravity here. Zero. Okay. The equations used in 2.1 are intended for flat Earth approximations. Hence, they do not include terms that transform the NAD frame to an Earth-centered inertial ECI frame. These terms would be needed for simulations that require modeling of the missile flight path over a spherical rotating Earth, such as simulations of ballistic missile trajectories. Okay? Now, Let's go through this again so that there's no fucking ambiguity, vagueness, or confirmation bias. The equations used in 2.1 are intended for flat Earth approximations. Where's 2.1? Here goes 2.1. These are the equations that are intended for flat Earth approximations, okay? Now, they go on to say, hence, they do not include terms that transform the NED frame to an Earth-centered inertial ECI frame. Those terms would be needed for simulations that require modeling of the missile flight path over a spherical rotating Earth, such as simulations of ballistic missile trajectories. So what they're saying is very clear. You need different terms to simulate a spherical rotating Earth. All right? But in this particular case, there are no equations for a spherical Earth approximation because everyone uses the flat Earth model equations. And we've seen various flat Earth model equations, and here they all are. Okay? There's problems with the globe, people. It's not reality. The globe is not reality. That's why all of these 5 papers I've shown you, they all use the flat Earth equation approximations. There's no spherical rotating gravity fucking equations they're using because they believe we're living on a ball. They all believe we live on a flat plane surface. We operate in that environment. You'll still have naysayers. You'll still have them. Missile model. Oh, wait a minute here. Okay. Let's go to the next. Flat Earth, 6 DOF dynamics from Stevens and Lewis, aircraft control and simulation. Flat Earth. Check that out. Electrical engineers probably love that. Flat Earth 6 DOF model. Mass, torques, forces, constants, velocities, position, angular rates. Okay, let's see what else we can see. Okay, simulation function files. Flat Earth dyne.m runs the Flat Earth 6 DOF dynamics. Got anything in here for globe? Anything for globe? 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 Again, globe? I guess globe's not here. No globe. Sorry. Flat Earth? Here, Miss Crabtree. Here, I'm here. We know. You're always here. Okay, here we go. This is Flat Earth Dynamics. Computes motion dynamics for 6 DOF Flat Earth model. Wow. Computes, okay, using Quaternion formulation, derivation of state vector. Okay, that's good. All righty, what do we got? For this simulation, oh, we already did that. We already read that fucker. Okie dokie. So, that's it. I got nothing else to show you. Naval Postgraduate School. It's a thesis, 2011. You'll find this some bitch as well. Just type in Flat Earth Guidance Laws. So you want to bash universities, colleges, researchers, scientists, mathematicians, and say, well, they teach this, they teach that, they don't teach you the truth. They fucking are teaching you the truth. They ain't lying about everything. They're not lying about everything. They are teaching you the truth. You just were just too fucking quick to decide you ain't fucking learning what you want to learn because you ain't applying your fucking self. And if you don't apply yourself, you're not going to be able to dig in that fucking basket to find out what the truth really is. Because you don't want to be exposed to just the foundational understanding of how to fucking start searching for it. You think it's just gonna, the truth just gonna come out from out of the fucking corner or from under the bed and says, gotcha. It ain't, no. The truth is what you fucking are making it. I'm not making the truth. The truth is right fucking here, what I just showed you, 5 fucking documents. They use the flat earth model. Now it's up to you to decide if you're going to be man enough or woman enough or adult enough or responsible enough to start changing some of the shit that you're saying and revise or amend or, you know, take another direction to decide, okay, it's out there, the documents are out there. Where am I going to go now? Because there got to be an end game to this shit. What's your fucking end game? You don't have an end game? You ain't got no fucking game, period. You don't have nothing. You ain't got shit. But a couple of tens of fucking subscribers who still don't understand what the fuck it is you're putting out. They're believing everything it is you're saying. Every fucking thing you're saying. So that's it, people. You saw the information. Happy hunting. Good luck to you. I hope, you know, maybe I'll find some more information to help you guys out with this shit, but, you know, I can only just do so much. You got to apply yourself, and if you don't apply yourself, then, you know, you're living a half-truth and you're living half a lie. You're trying to prove 99 lies to discover one truth. So your job now is to turn those 99 lies into 99 truths. Because it ain't just one thing. There's 99 other fucking things you got to figure out. Remember, it's not what you know, it's what you can prove, people. Let me see what people are saying here real quick, because I haven't really seen the chat. My boy Negatorix, he's in there. Freedom awaits. Why do we always see the horizon at eye level? Oh, God, here we go. I don't know how to answer. You're going to have to research that one, whoever the Tiago Brandel is. Eye level. I don't know who these other people are. But it's been fun, people. I had a good time. I hope you had a good time. Check out some of my other videos. Make some comments. Don't fucking ask me stupid shit. You're an adult. Do some homework. Do some research. If you don't like what I said, you don't like the information that's put out. I don't give a fuck if you don't like how I said it and how I delivered it. Stay on fucking focus and target. Look into what it is I put out there. And if you can find anything that contradicts what it is I put out, let's share ideas. Let's see why it is that information says one thing and then you found something that says something completely different. All right? But if you're going to attack me, I'm going to tell you go fuck yourself. Because I'm not about that shit. I don't come on your fucking house knocking on your door calling you fucking names. So don't come in my house knocking on my door calling me fucking names. You don't like the information? Go find out what the truth really is. I'm not here to put out fucking propaganda and bullshit. I'm here to show you, hey, get you to thinking so you can start looking for yourself to make a decision for yourself. But one thing for sure is this. The entire system is not a fucking round-ass basketball or bowling ball. All right? I said it in one of my other videos. The entire system, all 5 layers, the outer layers, is shaped like an expanding, flattening ellipsoid. And you're only going to be able to see that view from very high altitude. What altitude that is, I'm not really sure. No human being is ever being able to go to that altitude and be able to see things naturally with their own eyes. Because the conditions at those altitudes are not conducive to support fucking human life. So there's a reason why. You only see the shit through rockets and fucking cameras, and you can't even trust that anymore unless you send up your own gear. So if you want to save the money and send up your own gear, send up your own fucking gear. Stuff that you trust. Other than that, be good to yourselves. Take care. Peace out, people. Have a good night.